The chi-square test of association is basically when you try to prove that there is association between the two variables. But in this case, again, all these chi-square, you do it for the categorical variable. So this session, again, we will undergo this session. First, we'll learn the basic concepts. Then we'll see what are the research questions which are for which we answer, to answer which we need the chi-square test of association. What are the assumptions and hypotheses for chi-square test of association? What are the commands and how do we interpret those commands? And at the last, the summary of all the commands. So like if the research question is, if I want to know that there is any association between gender and diabetes status, like gender can be categorized as male and female, and the diabetes as a presence or absence of diabetes. In that case, let's see this hypothetical example. In this case, okay, count all samples to be a part of your study sample. I have conducted a study and I have asked only 2 questions from these study subjects, like what is your gender and are you a diabetic or not? So I have collected the data and I have made a contingency table. Now, what is this contingency table? It is a cross table, which is also known as the cross tab or a two-way table. It's an arrangement where the data is classified according to the 2 categorical variable. So there is a 2x2 contingency table. In this case, you have got 2 categories of each of these variable, diabetes as no and yes, and male as gender as a male and female. So this is the 2x2 contingency table. If you take one category having 3 levels, like in this case, you can see BMI has got 3 levels. So that will be like, and the diabetes 2. So it will be a 3x2 category. And this is known as the 3x2 contingency table. So just ponder on this slide for a few seconds. You can see there are 3 case scenarios. And now tell me, even if you don't apply any statistical test, can you say that in which case there will be association, there is a slight possibility, or there is no possibility at all? So I'll see in the chat box what you people are writing. So Neeraj is writing significant association with in 3. Okay. 3 possible. What about 1 and 2? Nidhi is also writing 3 significant. 2 slight possibility. Viral is writing. Okay. 1 not possible. Yes. So you are right. Santosh is writing 2 and 3. So yes, you are right. If you see this, first is there it seems that there is no association. Second, there can be some possibility. And third, it seems that there is a definite possibility. So there are, in first case, no association, some and there is a strong association. So what are the research questions? So the first research question could be, is there any relationship between the BMI categories, where I have categorized the BMI having normal, overweight and obese, and history of cardiovascular disease status, like present or absent. The second research question could be association between the surgical technique X and surgical technique Y, and occurrence of infection is having 2 categories. The third could be the association between the quality of sleep. Again, the quality of sleep is having 2 categories, good versus poor, and versus the academic performance, that is also good versus poor. So in all these research questions, what have you observed? That there is a categorical variable. Both the variables are categorical in nature, and we are trying to look for any association between those categorical variables. So the appropriate statistical test for such research question is the chi-square test of association, which is also known as the chi-square test of independence. Now we call it as a chi-square test of independence because in hypothesis, the null hypothesis, what we form, we say that the 2 variables are independent of each other. So that's why if we refute this, we say that there is association. Both of these are opposite to each other. That's why we have got 2 names for this test, which is known as the chi-square test of association or chi-square test of independence. But again, like correlation, we can say that the presence of association here, it doesn't say that it is causal in nature. To say that one variable is causal for the other, you need to satisfy the Hill's criteria for causality. So the underlying assumptions for this chi-square test is that there should be two categorical variables. There can be two or more levels for each of these categorical variables was having more than two category. And there should be independence of observation. We have seen what is this independence of observation means. That means if you have counted one individual, maybe if he's a diabetes, you cannot count that person again in non-diabetic. So there will be separate people in each of these two groups. That is known by the independence of observation. And it should have relatively large sample size. That is, we say that large sample size because then the expected cell frequency will be more than 5. So Neeraj is asking the difference between the association and correlation here is only based on the nature of data. Yes, the nature of variable. So in one case here, you can see that the both variables are categorical in nature. Whereas there in case of a correlation, the both variables were continuous in nature. Otherwise, both are test of association. Yes, there is more to it. More is only in that sense. In both the case, we have got an effect size. The correlation, the effect size is the value of correlation coefficient itself. Whereas in chi-square, you will see that there is a phi and Kramer V value, which tells us about the effect size, whether it is a strong, medium, or a weak association. So definitely both these tests, correlation and chi-square of test of association, it tests the association, none test the causality, and it's only the nature of variable which is different in both these cases. But there is a difference in case of a chi-square, there should be independence of observation. And I mean, obviously the assumptions are different for both these sets depending on the nature of the data. Did you get your answer, Neeraj? Or do you want something more? Okay. So now independence of observation, we have done this, but again, just to reiterate this, that there is no relationship between the subjects in each group. We also call this as it is the opposite of paired value. So we will see in the McNemer test and paired t-test that we define something called as the paired value. So whenever there is a relationship between the variables, like if you design a research question, you take 10 couples and you keep all females in one group and all males in one group, and then study the presence or absence of diabetes. Will that be an independence of observation? Please type yes or no. So question I'll repeat once again. In the same case, which I have shown you, like I have asked two questions. What is your gender? And what is your, maybe the status of diabetes? Or you can ask, so in this case, can I take 10 couples and ask regarding their gender and maybe the diabetes status? Or if I ask the status of contraceptive use, can I take 10 couples, have 10 females in one group, 10 male in one group, and may ask regarding the uses of maybe one or the other? But in male and female, the contraceptive will not be a good example because the two cannot have the same sort of contraceptives. So that will not be perfect, maybe diabetes. So can we say that the independence of observation hypothesis, I mean assumption is met here? So Pradeep is writing yes. Okay, anybody else? So ideally the answer will be no, because they are related to each other. Husband and wife, they are related to each other in many things. So that's why you cannot keep all male in one group and all female in one group and say that no, these many are diabetic and these many are not. Maybe the history of cardiovascular disease, because many diseases that are dependent on lifestyle. And if the two people are living together, then there is a observation will not be independent. That's why we say that the two person in each group should not be related to each other. Neither they should be husband and wife, nor they should be twins. There can be twin pair in one group, like one brother in one and the second in the other group. So yes, Neeraj, that is right. We cannot test this assumption through statistics. through SPSS or through Jamovi, there is no objective way to test this. This is a study design issue. So when you are recruiting the individual, then you have to take care of these things. So this is a study design issue. This you cannot check over the Jamovi or SPSS, right? This is a study design issue, and you should ensure this while you are designing the study. You should ensure that you have used this independence of observation concept while you are recruiting the individuals. Is that right to all of you, or should I repeat this concept once again, or is it clear? One of you can say yes or no. Pradeep is writing okay, but I cannot see anything now. Again, Pradeep is writing yes. Neeraj is also writing yes. Okay, then I can take 2 yes as a proxy yes for everyone. So the relatively large sample size, why we say relatively large sample size? Because, if the sample size is large, then at least we will expect that the expected cell frequency in each cell is more than 5. If the sample size is very less, like if you have got 30 samples, and if you're making 2 by 2 table, there are high chances that in one or the 2 cell, the number will be less. Maybe many times we have seen PG students coming with a 2 by 2 table, or they make 4 by 4 table. So in 4 by 4 table, if the sample size is very less, in each cell, the number will be very less. So the expected will definitely be less. So we always advocate that you should have a large sample size. If not, then you can club the categories that we will see. That if 4 by 4 table is showing a very small number, you can club the category and you can make 2 by 2 table, because this is one of the assumption that the expected cell frequency should be at least 5 for the majority of the cell. Now, what is the null hypothesis? So null hypothesis states that there is no relationship between the variables, whereas the alternative hypothesis states that there is a relationship between the variables. So now the concept of expected frequency, although I have shown it, so if you take the null hypothesis, like you say that there is no relationship. So you take that a proportion and you define the count in each cell as if the null hypothesis is true. That means there is no association. So if the 2 variables are independent of each other, then the expected count and the observed count, they both will be the same if the 2 variables are independent of each other. So that's the concept of expected frequency in a cell. And statistically, we define it like expected frequency. All of you know that it is the row total into column total. In denominator, we take the sum total. But ideally, we don't do it. The system or the software calculates it. But if you want to know it statistically, this is the formula to calculate the expected cell frequency, that it is the row total multiplied by column total divided by sum total. Now I was talking about the effect size. Now what is this effect size? So if the chi-square value is significant, it says that it is 0.01. Now what is the strength of this association? Because in Pearson, by the value of Pearson correlation coefficient, you can say that the correlation is strong, medium, or small. But with the chi-square p-value, that p-value tells you regarding the statistical significance, whereas the effect size tells you regarding the clinical significance. Because if you increase the sample size very much, then definitely, even if something is clinically not significant, it will become significant. But the statistical significance has some value in clinical significance? So that answer we can give by the effect size. So effect size tells you how clinical that significant statistical significance is. That means effect size tells you clinically how should we go about it. So if in the chi-square, the value of phi and Kramer V. So here you will say the value of Kramer V, because phi is there only for 2 by 2 table. Kramer V can be there for both 2 by 2, 2 by 3 and 2 by n by c table. So if the value of this Kramer V is 0.1, we call it as a small effect size. If the value of this strength of association or this Kramer V is 0.3, we call it as a medium. And if it is 0.5, we call it as a large.